Hi everyone. So today we are going to learn Kubernetes from the very scratch, from the very beginning, and no prior knowledge is required for it. And I'll try to explain all the concepts and all the terminologies in as plain and simple words as possible. So let's start. So imagine deploying an application that can automatically scale, heal itself if something breaks, and run on thousands of servers across the world. That is exactly what Kubernetes helps companies do. So in this course, we'll learn Kubernetes completely from the scratch. So what we'll try to learn is what is Kubernetes. The K8s is a short for Kubernetes. I'll explain in a while what it means, what containers are, what cloud native means, why Kubernetes became so popular, right? So these are some of the few introduction topics that we are going to cover. So let's start with what is Kubernetes. So before Kubernetes, companies deployed applications manually on servers. So now this created a lot of problems for the companies, and some of the problems that companies faced were that it was hard to scale, right? The downtime during updates were there, and it was difficult to manage, right? And then therefore there were also infrastructure issues. I'm typing, so you don't have to spend time taking notes or anything. You can just listen and try to understand the concepts. So these were some of the problems that existed before the Kubernetes came into the market. Now then came containers and Kubernetes, right? So if we talk about the very basic and simple definition of what Kubernetes is, so Kubernetes, in very simple word, is an open source container orchestration tool or orchestration platform. Now that may sound complicated to you, so let's simplify it. First, in order to understand it, we will have to understand what is our container orchestration means, right? So let's see. Now, if we talk about the container orchestration, we need to understand the containers package application with everything they need to run. But what happens is, in large companies, there may be hundreds of, even thousands of containers, and there could be millions of users. So managing all those containers manually becomes impossible. Now here is where Kubernetes comes into play, and it automates that management. So what it does is it decides where containers should run, right, when to scale applications, and when to restart apps, and how traffic should be distributed. So this is how Kubernetes automates all the management that is required and that was previously done manually. Now the real world analogy that you can think of Kubernetes, and which is very commonly given whenever if you pick a course on Kubernetes, is like think of like containers as ships carrying goods. Now Kubernetes, it is a captain managing all the ships, right? Like deciding where they go, like deciding where the ships go, replacing broken ones, right, and balancing traffic, and also managing resources. So this is a perfect analogy that you can think of for the Kubernetes and how it works. Right? That's why Kubernetes means helmsman or pilot in Greek. We call it K8s because there are literally 8 letters between K and S. So in short, this K8s is used to refer to the Kubernetes as well. Now, next important thing is why Kubernetes became so popular, right? Now, the big companies like Spotify, Google Cloud, Amazon Web Services, and Microsoft Azure use Kubernetes because it provides lots of features and it has all the benefits that comes with those features. So let's talk about those features and then benefits, right? So the first feature that you can think of is auto scaling. What it means is it handles more traffic automatically by itself. It is also another feature is self-healing, which means that it restarts failed apps, right? So previously we talked about like where containers should run, when to start applications, when to restart apps. So this is right, balancing traffic. So when replacing the broken ones. So that is exactly what we are referring to by self-healing, right? And now another important feature is high availability. Now what that means is it can create multiple replicas, stay running. This offers a lots of very important benefit. We'll talk about it maybe in this or next video. And the feature is portability. What this means is it works on cloud or local servers perfectly well. So these are some of the reasons that Kubernetes became so popular as a container orchestration tool. Now let's moving on to the next topic, which is what are then containers. If you have seen my last video series on Docker, you might have decent understanding what containers are. But let's dive a little bit deeper into it. Before, Kubernetes applications were usually deployed directly on servers or virtual machines. Now this caused problems like when the machines were deployed on servers or machine. I can write like when apps were deployed on virtual machines, right? So some of the problems were like dependency, conflicts, environment mismatch, and also high memory usage. Now containers, what they did was they solved this problem. So right, so if we talk about the very simple definition of container, you can say that a container packages application code, dependencies, libraries, and configuration files into one portable unit. It simply means it runs the same everywhere. So in my Docker video series, I explained a concept which is very common in software engineering, and it is called that it runs on my machine issue. The name of the issue is it runs on my machine issue. What it simply means is it is quite possible that a particular app might run on your system, but on someone else's system who might have a separate, different operating system, maybe Linux or OS or Windows, it will not run over there because your application, your dependencies are installed on your system, but not on theirs. So this will naturally cause all sorts of conflicts, and this containers solve these problems. So that is why it runs the same. So this is why when we say that it runs the same everywhere, this is what we mean by this. Now, why containers matter? Now, the containers are some of the few benefits of containers are the first is it is portable. It means it run anywhere. Second, it is lightweight. It uses fewer resources, which is very important for bigger companies, and which is fast as well. It is start quickly. And then it is scalable. Like it is easy to scale automatically, or you can say easy to replicate. So now some of the most popular container technology that is there in the market is called Docker. Docker helped popularize containers globally. Now the important terms when we talk about the Docker is since I've already talked about the Docker in my last video series, Docker for beginners, you can refer to those videos. I'll try to paste the link in the description as well. Now, container image. This is very important and common concept in the Docker. When you talk about the Docker, it is simply a blueprint, or you can also say template for creating containers. And we also already talked what a container is. And another important terminology that you need to remember is container registry. A place where images are stored. So these are like few examples that you can think of or Docker Hub. These are the examples of container registries, or Google Artifact Registry. So this was very brief mention of Docker and what are Docker images or container registry, right? Now, the next section that we are going to talk about is what is cloud native. I'm just trying to give very brief introduction in as simple words and as simply as possible, so at least you can have a basic understanding and you are aware of the terminologies used, so you are not completely naive or about this containers, Kubernetes, and Docker. So if you talk about the cloud native, you'll hear this term a lot in Kubernetes. It simply means the building applications designed for modern cloud environments, right? So these apps are designed to scale automatically, right? And recover quickly, deploy rapidly, and work across cloud providers. Now, some of the cloud native technologies that you can think of and examples are like containers, Kubernetes microservices, services meshes, and declarative APIs. So these are some of the examples of cloud native technologies. I can just write it over here, so you can always refer it. Like right, containers, Kubernetes, microservices, and declarative APIs. You can also go and search into more detail of this. One important thing is Kubernetes is managed by CNCF. Right, so Kubernetes is managed by Cloud Native Computing Foundation, and CNF supports. What CNF does is it supports Kubernetes, Helm, and Link. You can search more about these terms on your end, and it will give you a better idea of what these technologies, what these tools are. So if you move to the next part, and if you talk about very briefly about the Kubernetes architecture. So Kubernetes setup is called a cluster, right? So this is what the Kubernetes setup is called. Now a cluster has few components which are important to keep in mind. So I'll write component over here and each of their purpose. So first component is control plane. What it does, it is, you can think of it as the brain of Kubernetes. Second is worker nodes. I'll try to give you a picture of this so you can visually understand it as well. Right, worker nodes, you can think of it as something which runs applications. Right, and then if we go a little deeper into what is happening over here. If you go a little deeper into like what control plane is, so you can think like it makes decisions like where parts run, scaling, scheduling, and monitoring. Sorry, my bad, it's monitoring. Right, so these are some of the decisions that control plane does. In fact, it makes all the decisions about scaling, whether to scale down, where parts should run. If a system does not need lots of parts, it will manage those parts within a specific server, and it also monitors for automation, for scaling and stuff. And if we now move to what is a worker nodes, very briefly, worker nodes mean that worker node actually run the applications and containers, right? You can now so this is very brief architecture of the Kubernetes, and it has in fact 3 or 4 main components, right, or main blocks, you can say. And the most important is the control plane, and then it is worker nodes. Now, why learn Kubernetes? Because it is used in DevOps, data engineering, backend development, cloud engineering, and platform engineering. So learning Kubernetes helps you understand modern infrastructure and deployment system. So in the next chapter, what we'll do is we'll install Kubernetes. We will install Docker, kube control, minikube, then create our very first Kubernetes cluster locally on Windows. In fact, I'm using Mac, so just in case I might shift over there as well. So if this video helps you understand Kubernetes, you can keep following for more videos from beginner to advanced Kubernetes series. Right, see you in the next video. Thank you.